Welcome back to Area Diesel Service. So today we have another exciting collaborative episode with fellow YouTube content creator Red Poppy Ranch. OGs of the channel will recall one of our early attempts at collaborations and content creation was with our good friend Heath over at Red Poppy Ranch. I think we did him a turbo and maybe some fuel injection work. Don't really remember. We'll drop you a link. It's been a little while since we did it. If you have not come to us from Heath's channel, please go over there, check him out, and tell him that we sent you. He's a little bit different type of channel than our normal crusty, rusty, will it run restoration, but a fascinating and prolific channel nonetheless. Heath is a modern homesteader of the off-grid variety, and this dude has single-handedly, over the course of the last several years, built one of the most beautiful and significant off-grid arrangements that I've ever seen. A one-man wrecking crew capable of anything: mechanical, plumbing, electrical, excavation, equipment repair, restoration. I'm telling you, the dude is modern-day jack of all trades. Heath has a project going on over at the ranch where he is marrying two trucks together, so another Frankenstein of sorts. The chassis and running gear out of a 1990 F-Series Ford pickup. This would be your 7.3 liter IDI, indirect injected, the predecessor to the 7.3 liter Powerstroke. Naturally aspirated variety, at least at this particular point. The chassis is supposed to be in prime condition. I think it's got about 140 clicks on the meter. And as far as the condition of the chassis and running gear and engine, maybe with the exception of this pump, it looks to be in pretty darn good shape. His project is to work the bugs out of this chassis and engine and running gear and then marry it to a Bumpside Ford, your 69 to 72 F-Series Ford pickup, right? A classic that we all very much love out there. And he's putting that body on this chassis to make what is his ultimate toy. As far as why this is here, I think when he resurrected or acquired this chassis, it didn't run. So it's been sitting around, likely to be a case of the proverbial SCHMOO, but we're going to find out. Nailed it. Here she is in all of her glory. So what is it? This is a Stanadyne Rotary style, distributor style diesel fuel injection pump. Specifically a DB2 831-4821. DB is the style of pump. This one happens to be of the automotive variety. 2 referring to the number of pumping elements inside of the head and rotor. 8 cylinders. The 31 is representing 310 thousandths diameter pumping elements inside the head. And the -4821 is the code for this pump's specific bill of materials and calibration specifications. DB2 831-4821. This is a remanufactured pump. I don't know by who. It says 4 of 96. So perhaps this was a rebuild from that many years ago. Don't rightly know. I can tell you a little bit of what I know. Engine driven here, magic happening inside of here with the pumping elements and the head and rotor distributing the fuel around to the different cylinders here. This is fuel inlet. It's got a vane pump in the back of the pump, pressurizes the housing. This is return fuel back to the sump. shut-off solenoid, cold start, timing piston in the bottom of the housing that uses pressure and or that lever to roll the cam ring to operate on the effective timing or fuel delivery, timing window, name tag. This is one of the several variants we find on the 7.3 IDI, and a lot of them are basically interchangeable. This thing is conceptually very similar to the pumps you've seen us do before of the construction or agricultural variety, especially down in the guts, down in her innards. Very, very similar. Up top, just a little bit different. It has an electromagnetic shutoff solenoid under the top cover like many of the other pumps that we have seen, but it also has a second device here for cold start. This electromagnetic solenoid opens a valve in the return connector here, and it relieves the restriction that we generally use to build housing pressure inside of the pump. We do that so that the housing pressure is not combating the operating side of the timing piston. When we go cold start, we want maximum advance. We give full supply pump pressure to one side of the timing piston, and we relieve the other side, dumping housing pressure and letting it go to zero. Once it fires off, we quit commanding that, and the housing pressure restriction returns. Housing pressure is restored to whatever the specification is. Little different there, certainly not rocket surgery, but not one that you'll see on your common agricultural or construction type pump. This contraption here, I am actuating the throttle linkage. When I do that, this lever gets actuated. When you give it throttle from the foot feed, it turns this face cam, and it's got a ramp on it, and that face cam operates on this roller, and that roller on this lever, and that is operating on the timing piston in the bottom of the pump. So the timing piston operates as per usual with pressures from the supply pump and the magic that happens inside of the pump. But this pump has another feature in that when you give her the onions as such, it advances it for you additionally mechanically through that contraption. Common failure mode of this style pump are really in the timing piston area, and the bore in the housing will wear. The timing piston clearance will become excessive. The fuel pressure can no longer operate on it and move the piston effectively. And what we'll end up doing, if that is the case, honing the bore, getting an oversized piston to restore factory clearance. The next common thing, this face cam, it wears where the ramp meets the roller. And then the rest of it should hopefully just be your common stuff. Gasket and overhaul kit, metering, delivery valves, blades and liners, things of this nature. Hopefully that makes sense, because that is about as best as I can understand it or explain it. The complaint was just completely dead, right? Won't pump any fuel. This thing's been sitting around. The SCHMOO takes off, plugs up the passages, seizes up the valves, locks up the plungers, and the thing won't pump any fuel. Tear it down, clean it up, inspect it, replace the worn components, reassemble it, calibrate it, paint it, and ship it. But you just never know what you're going to get into. We'll get a work order started. We'll pass it back to the fuel shop. Corey is going to be your resident pump expert. He's going to give you the full feature right along. We'll let him do his thing. We'll meet you back at the parts counter to wrap it up.
Hey everybody, Corey here again. I got this pump, this DB2 Automotive pump here for Red Poppy Ranch. I know Kurt kind of went over some things with you. What I've looked on my Stanadyne page, it said that this particular one is supposed to be on a 90 to 92 Ford 7.3. You know, for your Ford pumps, you got your 7.3 and your 6.9. For your GMs, you got 6.2s and 6.5s. Whether or not, you know, I don't know exactly what this one is on. Obviously, it's a Ford, but whether what year, if my site is actually 100% correct, regardless. Got this pump here. It does spin over, so that's a good sign. I could kind of tell that it looks like it's going to have some fuel contamination in it, like some biodiesel that's set up. Luckily, it does still spin fairly good, so that's a good sign. But we will see what it looks like on the inside. The outside doesn't look too bad. It's a little dirty, but nothing out of the ordinary, so that's no big deal. I already got my fittings wrote down, so I don't have to worry about that. Other than that, I'm just going to start tearing into it. I'll explain some things as I go. What I'm hoping for, doing this later in the day, putting our sonic cleaners, and I'm hoping to let it sit overnight to kind of clean up. Luckily, I should have all the parts, but there's a couple that can be kind of hit or miss. But I'm going to get into it. First, obviously, I got to cap it up and clean it, blast some of the dirt off so that way it goes a little bit easier through the process here. Obviously, we cap it up so I know the beads get into it. The water is one thing. It's not as big of a deal since I'll be tearing it right down, but I don't want beads to get in the head and stuff like that. For the most part, I'm not going to take too much stuff off. I'm going to take a couple things off before I clean it up. Over here, this little pin right here. It's kind of hard to see, but there's a little pin. Goes through the shaft right here. That is just for his transmission module just to work off of, but that pin comes in the kit, so I can just throw it away. I'm going to take this piece off here. I'm going to clean it up separately. Just because then I'll be able to clean up the rest of the pump a little easier if I take this off now. And then I'll just take the tag off. Okay, that's pretty well it for that. I will go clean it up, be back, and start ripping this thing apart. Got the pump all cleaned up here, got the caps off of it. Let me get his fitting off here, we'll see. One thing I didn't check. I'm sure this thing is probably still full of fuel, which I didn't really check to see. Yeah, so even here I can tell that this thing here is... you can't really see it very good. But there's some crud in there. Some SCHMOO, as Kurt would say. Let's see how full this thing is. Oh yeah, she's full. I have to go drain that. It is always nice if before you send your pump in, if you drain the fuel out, it's not that big of a deal. The pan is kind of dirty here, but I'll at least get the gist. I'm going to drain it in here and we can kind of look to see what I think of the fuel quality. I don't know if he put any new fuel in it just to see if he could get it to run or if it's still just old fuel. We're going to find out though. Do a little investigating. Actually, the fuel looks pretty good. So I would say he put new fuel in it. Oh yeah. It's definitely new fuel. This top cover off. Oh yeah. She's nasty. Not the worst I've ever seen. It's a little early look here. You can kind of see the brown haze there. That is from biodiesel. Biodiesel that's sat for time has now started to change chemically to not good things. Anyways, got your main shutoff solenoid here, and then we got our cold start solenoid here. There's a piston that goes up and down, and there's a little pin that goes through that hole right there, and that relieves the pressure, lets your advance move for cold start, gives you more advance for start, helps the engine run a little smoother during those cold winter days. Anyways, gotta take the shutoff solenoid out first. So there isn't really much differences between the Ford pumps and the GMs. The biggest thing about them though is that they're opposite. So Ford pumps run clockwise, and everything, your rocker arm, your face cam, these two solenoid clips here, they're on the left side of the pump. Where on GMs, everything is flipped. So GMs also run counterclockwise in comparison. But other than that, really, they're about the same. The end cone is different, and the housing's different. The way that they're mounted. You know, Ford pumps run a mounting O-ring, where GM will run a mounting gasket. Back in the day, here's a little history lesson for you. Area diesel history. Long before my time, especially coming here. I was told from the guy that trained me that in these pumps' heyday, there was one or two guys in here. That's all they did, was just automotive pumps. Day in, day out. As many as they could get out, supposedly. They were that, popular. Back in the day, they ran these for, I can't remember how many years these things ran. I know it was a good, decent bit. But, they were work trucks. They were on the farm, pulling stuff. And then now, people still run them. Some people run them just as hobby trucks. Other people still run them on the farm. But yeah, back in the day, I guess they just ran as many as they could. They just had that many. Also, I know back in the day, so for GMs, you have your regular 6.5 pump, then you have a 6.5 electronic pump. Well, 6.5 electronics were just junk. They never ran right. He said that he would get a truck in, you'd have to put 3 pumps on it just to get one to work right. They were just a bad design. So anyways, now, back in the day, they did a lot of these, and now I maybe do 10 or 15 a year. I just don't really see that many. They've kind of grown out of their lifespan, along with other pumps as well, but yeah, I just don't really see as many. And it seems like everything else. They come in threes, you won't see any in for 3 months, and then you'll see 3 in a week.
Class is dismissed.
So anyways, this is that cold start. So this piston goes in and out here. This little pin sticks out, and that's what goes into your return connector. So that just pushes on that little check ball in there. So this here's your rocker arm. So you have your face cam, rocker arm, and there's a little plunger underneath this arm here. So basically this is like an early light load advance. So you go to full fuel. This holds as much pressure as it can against your piston, so your piston doesn't move as much. So at full load, you might be getting, I think it's normally around 3 degrees of advance. But then as you let off the throttle, this roller goes down this face cam. There's a ramp here, and see, you can kind of see the arm work back and forth. And basically then it tilts up, relieves pressure on the piston, so then you'll go from 3 degrees all the way up to around 10 degrees of advance. It's a early light load advance. More fuel, less advance, less fuel, more advance. It's how all light load advances work. Take this rocker arm off. There's just a little Jesus clip on either side. Just take one off, pull the little pin out, pull your rocker arm out. I'm going to take this roller here. Those wear out. There's certain things on these pumps that you have to replace every single time. This roller is one of them. Same way with that face cam. I would say 95% of the time this face cam is wore out on this ramp. This one here has some wear to it. It's not the worst I've ever seen by any means, but it's definitely going to get replaced. So this here is your adjuster, the screw here. You screw it in to give you more pressure, less advance. And that pushes on this little piston right here. It's really pretty simple design. And it does work pretty well, honestly. These little plungers here, I replace them every single time. And there is a lip seal right here. It gets pulled out. It comes in the kit, so I don't have to worry about reusing that. Now I'm going to take this face cam off. Split in the middle. Just helps relieve the pressure off the cam, and off that throttle shaft. You can just kind of see right there where it has that wear mark to it. And that's pretty common right there. That's very common for these to have wear there, and that's why we replace them almost every time. This guide stud is a adjustment. It's kind of almost like a torque backup adjustment, if you want to call it that. You know, it helps in between your full load RPM and your high idle RPM. It just kind of helps bring your governor back. Speeds up till your shift point, and then as it comes back down, it doesn't just absolutely just fall on its face. Helps just bring it back a little bit. There's an O-ring underneath there. This thing also helps with your high idle RPM, because if you don't have this thing set right, then you're not normally going to get the RPMs that you need. So like these things here normally run between 3,800 to 4,200-ish for your high idle, depending on the pump. But that's kind of the normal range. Let's pull this off. Okay, so I had to take that guide stud out in order to get this governor spring out. This here has this little groove here, so that fits onto your throttle shaft. And then there is a spring right here, a min-max governor. So this is your governor spring, this is your idle spring, low idle spring. And this thing is supposed to collapse, but it's a little sticky. And there is a spring on the inside. So that guide stud goes in here and it pushes on this little spring that's on the inside. And that's what gives it that extra little spring action to bring back your RPMs. Let's pull this out. This will pull out now. Okay. That's that spring I was talking about. So this side here clips on the housing, on the inside of the housing. This side here goes inside of the here. It's basically kind of like a return spring in a sense. That's your throttle shaft. There's 2 O-rings on it. Once I go to build it, then I'll try and mess with the camera so you guys can get a little bit better view, and I'll explain all this all over again. Once it's all cleaned up too, here's your governor arm. Hooks to your metering valve just like every other Stanadyne pump. However, automotives do not have a pivot shaft that goes through here. There's a pin on the inside of the housing that sets on. So, unlike everything else, you just pull that out. Get this metering valve out. The metering valve is actually pretty free. It does have a little bit of wear. Probably be in the replace pile. And there is a vent screw right here. The vent screw is what controls all your return. There's a wire in here. There's different size wires. These go from all the way from 0s to a 5. A 0 lets the most amount of return through, so it's the smallest wire. And the number 5 is the biggest wire, so it lets the least amount of return through. This here is just, it's an end cone locking plate for one thing, but also this is where I'm going to read my transfer pressure through on the stand. Take my end cone off. There's nothing else in there. Oh yeah. Here we go, guys. Look at that filter. It has all the crap on it. I mean, that thing is packed. Yeah, it's been a while since I've seen a filter like that. So, I would say most likely then, it probably did not start like that. I would assume that whenever he tried to restart the engine, if it's been sitting for a while, I have no idea, it probably pushed everything to here. Normally they are not like that. Even on contaminated pumps, I don't normally see it, packed on there like that. I mean, that guaranteed it feels like it's actually been on there for a while. So I'm not really sure. I would have thought that if it would have got packed in there here recently, that it would have been a little looser than that. But I could be wrong on that too. That's definitely not letting fuel through, so that's a big problem. Take the adjuster out. This is the transfer pressure regulator. There's a piston spring adjuster. Screw it in to give you more transfer pressure. Screw it out to give you less transfer pressure, things like that. Spring in there. And there's a piston inside here. These pistons here, 99% of the time I replace because they would just wear out. Here's your liner and blades. The blades stuck inside the rotor. So there's liner, blades. That's one set of blades. Okay, there's your other set of blades. Again, replace the blades almost 99% of the time. A little kitting screw out. Bottom here. Flip her over. Take the bottom plug out so I can get to the cam pin. These do not run a cam screw like other Stanadyne pumps. They run a cam pin. See how easy this is going to be to get out. Oh, whew. Ah, man, I got lucky there. Sometimes if they get real gummed up, you got to grab on them with vice grips and you got to slowly work it back and forth, and eventually you'll get it to yank out. Anyways, just a little bitty ball end. So the ball end goes inside the cam. This part here goes inside the piston, so it moves back and forth. So now, oh, that's not one to come out. That's a servo and a spring. I'll explain that here in a second. Okay. Yep. Piston has some wear to it, which is very normal for these. These housings, this piston runs inside of the housing. So it's steel to aluminum. The aluminum wears out. Then it bleeds past. You lose advance movement because it's not holding the pressure behind the piston. So it's bleeding past the piston and going out to return. It's a very common problem with these. Got your spring that's hooked to this little bitty servo here. So the servo goes in and out of your piston. You can see this hole right here. So that hole goes all the way through. And basically that servo lines up with that hole on either side and it floats in there. Depending on transfer pressure and pressure from your rocker arm, it adjusts and changes your amount of advance movement that you get. Anyways, yeah, that thing is worn out. I'm not going to reuse it. Most likely the housing is worn out. But we will check that once we get it cleaned up. I don't think I've ever had a head locating screw that tight. They're not supposed to be that tight. So basically we have got everything externally, most of the internal parts taken out. So now I just got to get the head out, which is what the mallets for. Could partially be because it's gummed up. It's not wanting to let loose. There we go. Yep. Again, you can see here, see how brown that is? That's from biodiesel. All those are brown. There's another weight, thrust sleeve. I'll get that drive shaft out here in a second. So you got your weight cage, your cam, head, and rotor. It's just like any other Stanadyne pump. Take the snap ring off. The main difference with DB2s, okay, let me rephrase, DB2 Automotives, is right here. Right at the end of my pick, you can see a little bitty check ball right there. And that check ball just keeps the slop out of the weight cage, is all it does. And it's almost kind of like a press fit, so you gotta work it back and forth. It's coming slowly. I also do this kind of slow so I don't lose that check ball. Sometimes it'll stay inside the weight cage and other times it will not. And then it rolls away and it's real small and then it vanishes. Okay, that check ball's gonna stay in there. Perfect. So you can kind of see it right there again, that little big check ball. Again, that just keeps the slop out of it. Is really all it does. Cam ring here. Whew. I'll have to determine on whether or not I'm going to use that after it gets cleaned up. It's kind of on the edge. Got your rollers and shoes. I'm sure these plungers are probably going to be stuck. Oh yeah. So that's another reason why I wouldn't pump. Because those plungers have to be completely free. Because these plungers go in and out this way as it rotates around that cam. So as centrifugal force and transfer pressure pushes the plungers out, goes against the cam lobes, and then it forces it back in and forces your fuel out. Real retaining ring holds these half moon plates, which are basically they are rotor retainer plates. Keeps your rotor from sliding out of the head. Ugh, yep, that's a little nasty. That's a little stuck. Might have to take this to a press. Yep, okay, yep, that's gonna go to the arbor press. So here's where your delivery valve is at. Might as well get that out of the way. You have your screw, your stop, and your delivery valve spring. Pull that apart. 3 parts. Delivery valve is still stuck down in there, which is probably going to stay in there until I run it through our sonic cleaner. You got your end cone O-ring. This pump has been rebuilt before because that's an aftermarket O-ring. I can tell you that right now because all the Stanadyne ones are yellow. And one of the other O-rings were a different color. So I would say this pump has been rebuilt before once. Okay guys, I got good news and I got bad news. Good news is I got it apart, but the bad news is last night whenever I was doing this, my camera died right at the end. So all you really missed out was the fact of the delivery valve was stuck inside the head and I got the drive shaft out. So unfortunately you missed a little bit, but nothing too crazy. You can yell at me in the comments later. But overall, I got it apart now. Basically, the inside of the housing don't look too bad. You can see, now you can kind of see what that stuff does to the inside of these. This particular housing, it's not quite as worn in the advanced area as I've seen, but I will I'm still gonna switch it out. We actually reman these housings here. So Stanadyne makes oversized pistons for these. It goes from standard size all the way up to 12 thousandths over. So we can reman these, which we do here. I'm hoping that I have one. I'm pretty sure I do. I basically didn't really run in anything too crazy. Once the camera died last night, I like I said, I pressed the head apart just with the arbor press. It was just stuck. Nothing too crazy. And then pulled the drive shaft out. I threw it in our sonic cleaner overnight. Basically, it was just one of the things that I couldn't wait till the morning to get the camera set back up, because I'm so busy as it is. I couldn't waste that, that clean time that I was really wanting for it to sit overnight. So that's the biggest thing. So I looked at it here this morning. It still needs some time in there, but it was definitely going towards the right direction. I'm assuming it'll probably still be in the sonic cleaner for probably a few more hours at least. Then I'll check it, and hopefully it cleans up as good as I like, and I won't have to do too much extra cleaning to it. So we'll just have to see. Just one of the things that's what you run into whenever you deal with these. Biodiesel has been unfortunately keeping shops alive, just because it makes pumps not work. Nothing that is unusual. I run into it every single day. I'm gonna get this thing cleaned up, and then you guys will see me back once I bring it all back in here, all nice and spick and span. Okay, so we got everything back in the room here. These are all my parts. This is all his original parts so far. Got the housing cleaned up. It looks a lot better. But like I said before, this Advance has some wear to it, so I'm really not gonna probably reuse it. Top cover will be fine. This is his. I don't have to worry about that. This rocker arm. Every once in a while it'll get some wear here on the sides, but this one actually looks pretty good. Face cam has some wear to it like I showed before, so that'll be replaced. These are his fittings. Turn connector here, I almost always replace those, especially like this one since it had fuel contamination. These are just the bolts that hold on that other piece. This transfer pressure piston, like I said, I almost always replace those. Rarely do I not. Plunger, replace it. That little bit of plastic roller, can replace it. Bolt for the face cam. This head and rotor. So these are all the parts I had on the sonic cleaner. And as you can see, even like this weight cage, it's pretty dang clean. I haven't done nothing to it. So the sonic cleaner did pretty good on this one. However, it's been in there, so it was in there all night last night. I took it out, washed it off a little bit this morning, and then I changed out the fluid, and it's been sitting in there all morning. So, it's been in there for quite a few hours. It definitely helped once I changed out the fluid. Ooh, yep, see? This cam, I'm going to see if I can get you guys to see it. It's going to be rough. Let's see, okay. No, not going to be able to see it. Anyways, there's a chip right here out of this lobe, which is common on these cams. So this cam here will be replaced. End cone here looks good now. All I did was buff the outside of it. Solenoid, drive shaft. Rotor don't look too bad. I think it will work fine from what I can kind of see here. I do gotta get this delivery valve out though. So here's a little delivery valve puller. So as I screw it out, the end here just gets tighter. It was already somewhat loose, so it should come out pretty easy. Come on. Yep, just like that. So that's kind of how that tool works. Which will replace that delivery valve. I did buff the outside of that head, so it's all nice and shiny now. Makes it look a little bit nicer. Thrust sleeve. Liner has some pits to it, so we'll replace it. This is that filter, so that filter was all plugged up before, and now it's more than clean enough to be reused. Advanced piston. Yeah, which you're not going to be... It has somewhere to it, you're not going to be able to see it. I've definitely seen worse, but it's still at that point where, you know, I don't want to risk it causing issues. Either me on the stand or for him later on. Yeah, these weights still have a little bit of crud on them, but it just wipes off. So now, I mean, you can see this weight. It's definitely a lot cleaner. Some parts just take a little extra TLC. Now this cam pin has the ball end. I have to measure this ball. Yeah, see, these balls wear out, and that one there is too small. Because basically if they get too worn out, then basically the cam will get loose on the pin, and then it'll want to jostle around a little bit more. Let's look at these rollers. Anytime there's fuel contamination, I have to look at these rollers. That one maybe has a little bit of a chip in it. They're not terrible, but they're not great either. Which I got rollers, so that's not too big of a deal. Especially for us here, you know, we're trying to provide a high quality service, so it's one of those things, when in doubt, don't risk it, because the less problems there is, the better. This little thrust washer here, you can kind of see that ring that's in the middle there. It runs there. That's from the weights. Normally it's only worn on one side. It's like this here, I'll just flip it over. That'll be still more than good enough. Servo. Plungers. Yeah, for how this thing looked originally, it's definitely cleaned up. Pretty more than good enough. My little vent screw here, try to make sure that this wire is free. I have most of the parts. Let's see if I can find a cam pin. Oh yeah, that one there is good enough. Okay, so don't gotta worry about that. Perfect. My wonderful box of goodies. Like I said before, we reman these housings here. So this is one of our remans. Comes with a new piston that's been sized to the bore size of the housing. So I know that's good. There's different lengths of these pistons as well, so depending on what pump number you got and stuff like that application, it changes the length of your piston, because between the length of the piston and the height of these plugs, that will change the amount of advance you get. So, you know, like I said, some get around 8 or 9, where other ones can get up to like 12 degrees of advance. Just all depends on the pump specs. So this one here, you can see, so that's an 8 over piston. Some go up to 12 over. An 8 over is really pretty common. So basically they line bore that out, hone it out to get it smooth again. Make sure that it's not barrel shaped or egg shaped. Put brand new bushings in it. And you grind the old timing mark off anyway. So that'll take a little bit. It's our reman cam. And all my other new parts. Luckily we had everything in stock, so I didn't have to order anything, which is always nice to be able to just go back and rebuild it as you go. Normally I'd say on average a pump like this would take me about 4 hours to tear it down, rebuild it, and run it and get it back out the door. That's probably about my average for most Stanadyne pumps. Sometimes you'll have one that maybe isn't quite as complicated, so it won't take quite as long, or you'll have some that have issues on the stand, so you got to fight them a little bit. It all just depends on the pump. Okay, I think I'm pretty well ready to go. Got my housing all cleaned up, got his fittings buffed up, so that's all nice and clean now. That won't cause any problems. That there looks fine. That's not going to cause any problems. So this pump here has this needle bearing in the front. Kind of see it there. I like to put a little bit of grease in here, lubricant, whatever you want to call it, just so it doesn't run dry on the stand and before the engine oil hits it on the engine. And I'll pre-lube this for the umbrella seals. A tube for my seals. Ooh, ninja. Okay, bit of lubricant on this. Makes the seal slide a little bit easier. Of course, they just go in the grooves on the drive shaft. This is the part that you guys didn't get to see because, like I said, my camera died. But there's 3 umbrella seals on these shafts. One faces out for your engine oil, and the 2 face in for your fuel inside the pump. So that way it doesn't leak out the weep hole. Some drive shafts are a little different. So some, like this one here, takes a snap ring. Some will take a big O-ring. Some will take this little wire doodad here. It just kind of depends on the pump and how they originally designed it. Can't really say necessarily any one is better or worse than the other. Those are all lubed up. Can't really go wrong here. Just got to make sure that the seals don't roll. That's the biggest thing. Here in a second. Let me move this camera over. Well, let me set the head, then I'll move the camera over so you guys can see a little bit easier. It's not like you'll be able to see anything at this point anyway. So basically on the inside of this there is a thrust bearing, a thrust washer, and then a wavy washer, and then a clip. Which basically the wavy washer gives you a little bit of thrust action, a little bit of cushion, so that way it holds everything snug. Okay, so that's good. Got a rotor. Find my delivery valve, brand new delivery valve. Spray a little juice on it. Stick that in. Got our delivery valve spring here. Got our brand new stop. That basically seals everything. It also limits how far that delivery valve can move. So that goes in. That felt fine. I got to torque this in to the specified torque. Can't go too little or too much. Otherwise you got problems. Put a little bit of calibration fluid on that. That spins nice and free. That's always a big thing too, is make sure that's nice and free. Same with these plungers. As you can remember, at the start of this, these plungers were stuck inside of here, which now they're completely free once they got cleaned. I mean, now, yeah, that's smooth as silk, so that's good. Shoe and roller. Shoe and roller. Got to make sure these spin, as you can see here. Maybe. Got to make sure those spin, because if these things don't spin, then they'll waste themselves and they'll ruin the cam. Then the pump comes back and you guys aren't happy, and I'm not happy because there's a warranty, you know, all them things. Hook air to this, make sure that stop ain't leaking, and then I will also check my roller. That stop looks good. I see no air bubbles. That's perfect. Put this in here. I got my spec sheet here. It's telling me everything I need to know, especially my roller. And we are actually high, just a little bit. So I'll probably leave it there for now. See how it runs on the stand, and then I'll determine on whether or not I need to change it on the stand. That's going to stay how it is for right now. That's part of gaining experience at this particular job, is the fact of knowing when do I need to mess with something, when do I not. It's one of those, is it going to create a problem now? Is it going to create a problem later? Do I need to determine if I need to act on it later, or do I need to do it now? Just things you learn as you go. Okay, so this is actually a reman cam, because like I said, his original cam had a chip in it, which this one looks good. You have to put this on in the direction of rotation according to the arrow on the cam. It's right here. You can just barely see it. Put that on the right direction. This one here is clockwise. Like I said before, Ford pumps are always clockwise and GM pumps are always counterclockwise. Got that little check ball in there. That check ball has to line up with this groove here. Technically that's really the only way it'll go, because it won't fit any other way. A lot of times check ball will be out and this will go on. So I said that is dang near a press fit. And that check ball pushed up a little bit, so I just need to tap it down. Otherwise that clip that goes in here likes to catch on it. So now this little clip here goes on your weight cage. This basically just makes sure it doesn't pop off. And I like to line that clip up with that check ball. Okay, I don't see any problems there. Got our end cone O-ring. Make sure that's seated all the way down. Got our rotor retainers. These go in a lot easier than they come out. We got our clip that goes around the outside of the rotor retainers. Now, like on a DBG pump, you know, I have to use this tool here. You know, I put the little ring over it and then I push it down over top of those, where this one, that keeper is a lot taller, so I can just use my fingers with it. Oh, liner. Got our liner here. It's another Reman product that we do here. Got the shop. Got our brand new blades and springs. Got our blades and a little spring in between. Some people call them blades. I call them blades. Some people call them vanes. It's just kind of how you learn originally. I think on the breakdown they are actually called blades. So that's why I refer them to that. Let's run a little brush through here. Didn't look too bad, but never hurts to be a little extra clean. You know what I mean? That's better. Got our brand new transfer pressure piston. Again, this regulates the transfer pressure inside the pump through this adjuster. Just gets adjusted on the stand. Whether I need more transfer pressure or less, I'll adjust that in or out. Controls a lot of things. It controls your advance, your internal pressure. It controls the fuel that you make through the head. There's just several things that it regulates, so that's why it has to be correct. Put some grease on the end of this end cone where it meets that O-ring that I put in there. Basically just kind of put that hand tight for now. I'll torque it in once I get it inside the pump. Now, this cam has two holes in it. One is the perfect size for this cam pin, and this other one is sloppy. So just kind of gotta pay attention to what you're doing. Make sure you get the right hole facing down. Otherwise you have to spin it around while it's inside the pump, and that's just kind of a pain. Got our weights. These open and close depending on speed and centrifugal force, which this is what regulates your RPMs. So yeah, as it speeds up, you know, these open up and it's trying to push this out. Well, then your piece here is trying to push it back in, and that's what gives you your RPMs. So basically that's trying to push out to your high idle, and that's trying to keep it down for as long as it can. So that's ready to go inside the pump. So grease on the inside of here so this head will slide in easy. My dot is to the top. You have to line the dot on the end of your drive shaft with the dot on the end of your rotor. If you don't, if you get it in backwards, it'll be 180 out. And then it won't run right, or run at all. That's to the top, and that's to the top. Okay. Ooh, okay. Nope, gotta go a little bit more. Let's try that, see if these bolts will go in. Oh yeah. Whew. Oh, stiff. Sometimes they slide right in, and sometimes you gotta really kind of work at them. I'm going to replace this metering valve with a new one, because the old one here has some wear to it. Now I'm going to tell you a trick I learned from the guy that taught me. This little spring here, that little wire, he always told me if you pull up on that, bend it up a little bit, that helps on your low idle underrun, which is basically if you are going and you let off the gas and it goes down to low idle, it won't go down and die, it'll actually pick back up on itself. This is what we refer to as low idle underrun. Basically it underruns your RPMs and then your engine can't keep up with it. Okay. Yeah, I'm going to have to put it flat, otherwise I'm not going to be able to get this in. So this is my governor arm This part hooks to the metering valve. This part goes on that thrust sleeve. And like I said before, whenever I tore it apart, these automotives do not have a pivot shaft. They have a pin inside the housing, which I could show you on the old housing, maybe. You can see it in there. So that's what this thing here pivots on. I can't really say that either design is necessarily better than the other, but this is a little easier to get it inside the pump. There we go. Okay. So that's working on that metering valve now. So you can see that metering valve move whenever I move that. That's basically your whole premise. So holding it back this way is full load, pushing it up that way is your high idle governor cutoff. So your weights are always trying to push it this way, and your governor spring is holding it back that way. So it's always opposing forces. My little vent screw goes in here. It's always a good idea to take this out before you pull the head out, because if for some reason that thing is sticking up a little bit and you pull that out, it'll score the inside of your housing, and then the housing will be junk because it'll be too deep and your O-ring won't seal it. So it's just a good practice to take that out before. Our bottom head locator screw in. Brand new O-ring on that. And these will get torqued in here once I get it in. Torque that in. That. Okay, that's good. It's a brand new piston, like I said earlier. The slot has to go up because this gets fuel through your head locating screw. So if you got that pointed down, then your advance is not going to work in the slightest. It's perfectly free, so that's good. That's perfect. Got our little servo here. Servo rides inside the piston. That's completely free. Main thing on a lot of these things is just making sure that everything is nice and smooth. Because if everything isn't moving smoothly, then it's not going to work right. It'll either give you false readings or it just won't work at all. Or it'll work just enough to where it'll get it out of here and then it won't work right on the engine. And it's one of those things, if you take the time and do it right the first time, then you don't have to take the time to do it again. And the way it's been around here, I ain't got much time. I'm always constantly going from one pump to the next. So I ain't really got a lot of extra time to be making mistakes. O-rings on this. You'll just be able to see me do this. So this here is that new lip seal. Goes in this plug. I have a tool that I use to tap this in. That tool sets that to a certain depth. Now you can see that's installed, and a brand new plunger will go inside of here. So as you can see, it sticks out a little bit there. That part there goes against the spring, and this part here is where this rocker arm goes against. So a brand new roller. Put our new O-rings on this. This is our throttle shaft. Put a little bit of grease on this. Can't forget this spring. That's nice and free. Put our little dust washer on this end, spacer, whatever you want to call it. Our brand new face cam. Of course, this one ain't got no wear, so that's good. I just kind of preset these to a certain point. I kind of know roughly where they need to be, but I gotta do the final setting on the test stand, which this is what sets my light load. Okay. Once I get the arm, I guess I put the arm on here now. So the pin goes through the arm like that. Put our new Jesus clip on here. Without stabbing myself. Okay, so now we'll see this arm move back and forth. So that pivot's on there. So full load puts the most amount of pressure on that spring in your servo. Light load puts the least amount. Like I said, as you move your throttle on the inside, it moves this constantly, and then that changes your advance as you're driving down the road. This here's your governor spring assembly. Like I said, this is your governor spring. This is your low idle spring. This spring here is basically just for your torque backup. Hopefully that'll hold it. I just put a little bit of grease on there so the spring don't fall out. Put this in. There we go. You can see now that governor spring is in there. It moves back and forth, but I still need to put the guide stud in, and this is adjustable. So this goes in and out depending on how far I screw it. Brand new O-ring. I'll leave this somewhat backed out to start. I kind of get it again. I kind of know roughly where it needs to be. So I put it close to that. It does actually give me a... So it gives me two different specs here. So it gives me a fuel spec. So it needs to be at a certain RPM. It needs to be at a certain fuel range. But it also gives me a length dimension. So it tells me the dimension from the back of the head to the front of the nut. And it gives me that dimension too. So technically they're supposed to be kind of both relative to each other, but most of the time it doesn't matter a ton as long as it works. So this is your retaining spring here. I got to clip this. There's an embossment on the inside of this housing, which I'll show you here. So you can see that spring clips behind that little embossment there. You can see that little groove. Sometimes these things go in first try, and other times it takes several tries. Nope. This can be a pain right here. Come on. There we go. Second time's a charm. So that is hooked on here, and the other end is hooked in that governor spring assembly. And like I said, it's just a return spring. I also think it helps it keep it from wanting to flop around too much. So that's all working good. So basically, as your weights move out, they push on that spring, and this thing here is keeping it forced back. So it's a real simple explanation. And that all has to do with RPMs. It's basically what regulates everything. This little idle screw looks like it's turned in too far. There's a spec on this throttle arm too. I might have to adjust this on the stand. Have to turn that in or out, and that changes my RPMs as well. but we'll cross that bridge later. Basically now I got left is the top cover section, which is my 2 solenoids. I already peeled the grommets off of this. I got to peel the grommet off of this one. Comes with new grommets in the gasket kit, so I don't got to worry about it too much. Now, this solenoid went in, came out last the first time, but it has to go in first this time. So once you get the shut-off solenoid in, you can't get this one in. Build this setup here. Follow my washers. Okay. Got that on. Put the new grommets on this as well. This little insulator keeps it from grounding out on the top cover. Okay, we are real close. Top cover O-ring. That looks good. Set this on here. Now I got my bolts. Go through here. That all feels good. Put my return connector on here. This helps regulate your housing pressure. There's a spring and a check ball in there. So you're supposed to get, I think, 8 to 12 pounds of housing pressure, which whenever your cold start solenoid is activated, it pushes up on that check ball, it dumps off all your housing pressure, lets you get more advance. Okay, so now all I got to do is stamp it. And then it is ready to run. Everything is moving correctly. Everything torqued down. So it's basically ready to go on the test stand and be ran off. So I'll get this pulled off, set up over there, and we'll see how she runs. Got the pump mounted up here. You kind of saw me changing the lines over and everything. Got the right lines, right injectors, right mounting plate. Got the pump warmed up so it's ready to go. It does pump fuel, but I haven't done anything past that. Didn't see any leaks right off the bat. Hopefully it runs perfect. Won't have any problems. One thing I'm curious about is I left his roller roller spec the same, so I didn't change it, so I'm kind of curious to see where it's going to land fuel-wise, whether it's going to be right on spec or a little over, a little under. That'll maybe tell me some things. There's my shut-off solenoid, so it's making sure it actually shuts off the fuel, which it is. Rarely do I have any problems with those. I checked my low speed shut off, which is with the shut off solenoid again. That works fine. Now on the cranking. So at his main roll-to-roller check, he was right at about 10% over. He was just under 10% over, which is perfectly fine. Yeah, we'll just head here. That's probably pretty hot. Yeah. It should make cranking here. It's a little close, but I think it'll be fine. It's kind of hanging up, so that's good. He doesn't have a ton of extra fuel at cranking, but he has enough to where it'll start the engine. It's over my minimum spec, let's put it that way. That's fine. I'm going to check my low idle. They're pretty close. Okay, I'm happy with that. Check so basically this is my cold start, so I gotta energize it because this is my shut off solenoid. So I basically just use a screwdriver and jump it, and that energizes this cold start solenoid. Okay, that's working good. Now it's time to go up and check my high idle and set my guide stud. So far, everything has really worked out pretty good. Basically checking this fuel spec here, and then I gotta set my base cam for my light load, and then that'll basically be it. See how close I got to my preset. We're close, but I do need to adjust it. Quite enough. I think we're gonna be close now. I think I finally got it. Yep. So now at my advance that I need, I'm getting the fuel delivery that I need. Yep. That's perfect. So everything worked out good. Vans came in good. RPMs were fine. All my fuel was fine. Transfer pressure was good. So far, this pump is almost ready to go back to him. I just got to unhook everything, take it off the stand. I need to air time it, things like that, cap it up, wash it up, and we'll send it back to him. But we're getting closer. Luckily, had no issues on the stand. The other automotive I just ran, it didn't have any issues either. So sometimes you get lucky. What do they say? A blind squirrel finds a nut every once in a while. Thankfully, everything worked out. Got the pump back in the room. I'm gonna hook up my air supply to my #1 cylinder, which would be this one. Basically now I'm just gonna spin this over until my rollers lock up. So basically I'm forcing air through the head, and it's going to force out my plungers, which is gonna force out my rollers to where they hit the can. And that's how I know whenever, I'm basically looking for a beginning of injection, which is what this is which is basically what I'm timing it for. And this here is my timing device. I need a negative 6.5 degrees. And it tells me all this on my test plan, what to set the timing to and stuff like that. Yeah, okay. Double check it. Yep, that's perfect. Here we go. Basically, I just want to repeat this multiple times to make sure that it is accurate. So I wouldn't want to send out the pump if the timing line wasn't accurate, which it's landing at the same spot every time. Now, I'll take this, give her an old kerschmack. Basically, you just stick that through the timing tool, and as I hit it, it just goes down and smacks the flange, and voila, you got a timing line. So you can just kind of see that little ridge there in the middle of that. That is what is actually making my line here on my flange. Which that looks good, very noticeable. It helps that this pump isn't going to get painted. Now I'm just kind of down to putting his fittings back on it, capping it up, making sure all the necessary holes are plugged up that need to be plugged up. I'll put this thing back on it as well. New O-ring for his inlet fitting here. Oh yeah, that's perfect. This is his little end cone locking plate. It has teeth in there to go with the teeth on the end cone. It also plugs up that hole where I read my transfer pressure out of. If you don't put this back in here, it will leak profusely. Try and get it lined up with the teeth. Yeah, that's good. Okay, that's right. A little pipe dope on his return fitting. So it doesn't leak. Putting in a new pin for his transmission thing. These can be a slight pain to go in. Of course, you don't want to smack it too hard. You don't want to hit that face cam, or you don't want to bend into that shaft or anything like that. That's nice and tight. That rod there was bent a little bit. Basically, it's capped up. All I gotta do now is just wash it up, put my name tag on it and paint seal it, and then it will be good to go back to him. The biggest problem we found was the fact that it had fuel contamination in it, which had the plungers locked up. So, of course, if the plungers are stuck, it's not going to pump fuel. If it's not going to pump fuel, it's not going to start the engine. I will say he probably will have to go through the rest of his system, you know, check his filters, stuff like that if he hasn't done that already. So that way, clean out his tank, so it'll have nice, good, clean fuel going to the pump, which will then go to his injector, stuff like that. He is definitely in a lot better shape than it was whenever it came in.
The SCHMOO strikes again. If you've made it this far, you followed along and you saw the entire process. Again, number one most viewer requested Stanadyne pump to be demonstrated on camera. There's a lot of these IDIs still out there. There's a lot of us doing our own repairs and trying to fix these old beasts. Hope you enjoyed it. I'll give you a quick summary and rundown. We all know Corey is the master of the rotary pump, and he definitely nailed this project again. What did we do? The usual full service repair and return. This one got a gasket kit, the liner and blades for the supply pump, the remanufactured housing because of the timing piston bore with a new timing piston, cam screw, standard metering and delivery valves, cam ring, and then the faceplate that we discussed earlier. Probably some other widgets along the way, but you saw the process, right? Bring it in broken and grimy and clean it up, tear it down, inspect it, get some parts, reassemble it, calibrate it. Do not paint your IDI pump and ship it back to the customer. Corey told me that this pump was in pretty good condition. It looked like the pumping elements, the actual business end of what's happening inside the magic box was stuck. And when they stick, they don't pump. And when they don't pump, your truck no run. This pump ran off and calibrated absolutely beautifully and without any issue or really adjustments. It was set perhaps just a skosh above factory fuel delivery when we got it, and we left it as such. Heath should be very happy, and I have no doubt that when he bolts this up, his engine's gonna light right off.
It's alive! It's alive! It's alive!
Okay, the $1 million question as per usual. What did it cost? We had the aforementioned parts and about 5 hours of labor in the fuel shop for a grand total of $977.87. A lot of money, especially on an IDI generation truck. These trucks are getting harder and harder to substantiate a $1,000 part, and this is the reason why we don't see that many of these in our fuel shop today. I know that many of you have seen this pump in supposedly a remanufactured condition on the internet for a significantly different price. If you find this online for $500 or $600, you won't ever catch me knocking somebody, but I would question what has actually been done to that pump. I can tell you that there's no way to get this level of component replacement and that amount of time and care from an expert for that price point. This is the type of product that we like to remanufacture. This is the type of job that we're comfortable performing for our customers, and this is the type of repair that we can sleep at night and know that we've done the absolute best job we can. But keep in mind, that is this pump, and that is as of today. Your results may and almost definitely will vary depending on the level of boat anchor that you send us or the level of SCHMOO inside your component. But know this, we're fair, We're honest, we're competent, and we would love an opportunity to earn your business. If you didn't come to us from our good friends at Red Poppy Ranch, please go over there, check them out, tell them that we sent you. These are some very high quality, God-fearing, dog-loving, virtuous people, and the content that Heath and Cedar are putting out is some of the most entertaining and interesting content we've seen. The dude is a true jack of all trades and a one-man wrecking crew and just a solid family over there. So tell them we sent you.
If you guys ever have any fuel pump needs, well, give us a call. Here to help. We got the knowledge, we got the tools, we got the stands, we got everything. Well, mostly everything. Don't forget where you watched it. Give us a like and a subscribe. And hopefully you'll see me another day.
If you find yourself in need of any diesel engine component, be it fuel injection, turbocharger, or anything else that might bolt to a diesel engine, please don't hesitate to reach out and let us know. If you do, and if you let us know that you learned of us through our YouTube efforts, we'll throw in some merch with your order, perhaps a couple of hats, pair of gloves. We're going to send Heath some of our area diesel service fender covers so he keeps the beautiful patina on that Bumpside Ford. Do me a favor, if you like what you saw, go down in the comments section, tell Corey, thumbs up, good job. The dude is a passionate and very skilled tradesman. And if you like the video, tell Mallory thanks for her efforts, because I'll guarantee you she's got more time invested in this than Corey and I combined. Cheer her on, let her know what you're thinking. That's it for now. Thanks for watching.